Is time travel possible? Science says time travel is possible, but probably not in the way you're thinking. Is time travel possible? Short answer, yes, and you're doing it right now, hurtling into the future at the impressive rate of 1 second per second. You're pretty much always moving through time at the same speed, whether you're watching paint dry or wishing you had more hours to visit with a friend from out of town. But this isn't the kind of time travel that's captivated countless science fiction writers, or spurred a genre so extensive that Wikipedia lists over 400 titles in the category, movies about time travel. In franchises like Doctor Who, Star Trek, and Back to the Future, characters climb into some wild vehicle to blast into the past or spin into the future. Once the characters have traveled through time, they grapple with what happens if you change the past or present based on information from the future, which is where time travel stories intersect with the idea of parallel universes or alternate timelines. Although many people are fascinated by the idea of changing the past or seeing the future before it's due, no person has ever demonstrated the kind of back and forth time travel seen in science fiction, or proposed a method of sending a person through significant periods of time that wouldn't destroy them on the way. And, as physicist Stephen Hawking pointed out in his book, Black Holes and Baby Universes, Bantam, 1994, the best evidence we have that time travel is not possible, and never will be, is that we have not been invaded by hordes of tourists from the future. Science does support some amount of time bending, though. For example, physicist Albert Einstein's theory of special relativity proposes that time is an illusion that moves relative to an observer. An observer traveling near the speed of light will experience time, with all its aftereffects, boredom, aging, etc., much more slowly than an observer at rest. That's why astronaut Scott Kelly aged ever so slightly less over the course of a year in orbit than his twin brother who stayed here on Earth. There are other scientific theories about time travel, including some weird physics that arise around wormholes, black holes, and string theory. For the most part, though, time travel remains the domain of an ever-growing array of science fiction books, movies, television shows, comics, video games, and more. While we don't accelerate humans to near light speed, we do send them swinging around the planet at 17,500 miles per hour, 28,160 kilometers per hour, aboard the International Space Station. Astronaut Scott Kelly was born after his twin brother, and fellow astronaut, Mark Kelly. Scott Kelly spent 520 days in orbit, while Mark logged 54 days in space. The difference in the speed at which they experienced time over the course of their lifetimes has actually widened the age gap between the two men. So, whereas I used to be just 6 minutes older, now I am 6 minutes and 5 milliseconds older, Mark Kelly said in a panel discussion on July 12, 2020, Space.com previously reported. Now I've got that over his head. The difference that low Earth orbit makes in an astronaut's lifespan may be negligible, better suited for jokes among siblings than actual life extension or visiting the distant future, but the dilation in time between people on Earth and GPS satellites flying through space does make a difference. The Global Positioning System, or GPS, helps us know exactly where we are by communicating with a network of a few dozen satellites positioned in a high Earth orbit. The satellites circle the planet from 12,500 miles 20,100 kilometers away, moving at 8,700 miles per hour 14,000 kilometers per hour. Then, according to general relativity, clocks closer to the center of a large gravitational mass like Earth tick more slowly than those farther away. So, because the GPS satellites are much farther from the center of Earth compared to clocks on the surface, Physics Central added, that adds another 45 microseconds onto the GPS satellite clocks each day. Combined with the -7 microseconds from the special relativity calculation, the net result is an added 38 microseconds. This means that in order to maintain the accuracy needed to pinpoint your car or phone, or, since the system is run by the U.S. Department of Defense, a military drone, engineers must account for an extra 38 microseconds in each satellite's day. The atomic clocks on board don't tick over to the next day until they have run 38 microseconds longer than comparable clocks on Earth. Given those numbers, it would take more than 7 years for the atomic clock in a GPS satellite to unsync itself from an Earth clock by more than a blink of an eye. We did the math. If you estimate a blink to last at least 100,000 microseconds, as the Harvard Database of Useful Biological Numbers does, it would take thousands of days for those 38 microsecond shifts to add up. Closing parenthesis. This kind of time travel may seem as negligible as the Kelly brothers' age gap, but given the hyper-accuracy of modern GPS technology, it actually does matter. If it can communicate with the satellites whizzing overhead, your phone can nail down your location in space and time with incredible accuracy. General relativity might also provide scenarios that could allow travelers to go back in time, according to NASA. But the physical reality of those time travel methods are no piece of cake. Wormholes are theoretical tunnels through the fabric of space-time that could connect different moments or locations in reality to others. Also known as Einstein-Rosen bridges or white holes, as opposed to black holes, speculation about wormholes abounds. But despite taking up a lot of space, or space-time, in science fiction, no wormholes of any kind have been identified in real life. The whole thing is very hypothetical at this point, Stephen Chu, a professor of theoretical physics at the University of Oregon, told Space.com's sister site Live Science. No one thinks we're going to find a wormhole anytime soon. Primordial wormholes are predicted to be just 10⁻34 inches 10⁻33 centimeters at the tunnel's mouth. Previously, they were expected to be too unstable for anything to be able to travel through them. However, a new study claims that this is not the case, Live Science reported. The new theory, which suggests that wormholes could work as viable space-time shortcuts, was described by physicist Pascal Corin. As part of the study, Corin used the Eddington-Finkelstein metric, as opposed to the Schwarzschild metric which has been used in the majority of previous analyses. In the past, the path of a particle could not be traced through a hypothetical wormhole. However, using the Eddington-Finkelstein metric, the physicist was able to achieve just that. Corin's paper was described in October 2021, in the preprint database archive, before being published in the Journal of Modern Physics. While Einstein's theories appear to make time travel difficult, some researchers have proposed other solutions that could allow jumps back and forth in time. These alternate theories share one major flaw. As far as scientists can tell, there's no way a person could survive the kind of gravitational pulling and pushing that each solution requires. Infinite cylinder theory. Astronomer Frank Tipler proposed a mechanism, sometimes known as a Tipler cylinder, where one could take matter that is 10 times the sun's mass, then roll it into a very long, but very dense cylinder. The Anderson Institute, a time travel research organization, described the cylinder as a black hole that has passed through a spaghetti factory. After spinning this black hole spaghetti a few billion revolutions per minute, a spaceship nearby, following a very precise spiral around the cylinder, could travel backwards in time on a closed, time-like curve, according to the Anderson Institute. The major problem is that in order for the Tipler cylinder to become reality, the cylinder would need to be infinitely long or be made of some unknown kind of matter. At least for the foreseeable future, endless interstellar pasta is beyond our reach. Time donuts. Theoretical physicist Amos Ori at the Technion Israel Institute of Technology in Haifa, Israel, proposed a model for a time machine made out of curved space-time, a donut-shaped vacuum surrounded by a sphere of normal matter. The machine is space-time itself, Ori told Live Science. If we were to create an area with a warp like this in space that would enable timelines to close on themselves, it might enable future generations to return to visit our time. There are a few caveats to Ori's time machine. First, visitors to the past wouldn't be able to travel to times earlier than the invention and construction of the time donut. Second, and more importantly, the invention and construction of this machine would depend on our ability to manipulate gravitational fields at will, a feat that may be theoretically possible, but is certainly beyond our immediate reach. Time travel via speed. This is the easiest and most practical way to time travel into the far future. Go really fast. According to Einstein's theory of special relativity, when you travel at speeds approaching the speed of light, time slows down for you relative to the outside world. This is not just a conjecture or thought experiment, it's been measured. Using twin atomic clocks, one flown in a jet aircraft, the other stationary on Earth, physicists have shown that a flying clock ticks slower, because of its speed. In the case of the aircraft, the effect is minuscule. But if you were in a spaceship traveling at 90% of the speed of light, you'd experience time passing about 2.6 times slower than it was back on Earth. And the closer you get to the speed of light, the more extreme the time travel. The highest speeds achieved through any human technology are probably the protons whizzing around the Large Hadron Collider at 99.9999991% of the speed of light. Using special relativity, we can calculate 1 second for the proton is equivalent to 27,777,778 seconds, or about 11 months, for us. Amazingly, particle physicists have to take this time dilation into account when they are dealing with particles that decay. In the lab, muon particles typically decay in 2.2 microseconds. But fast-moving muons, such as those created when cosmic rays strike the upper atmosphere, take 10 times longer to disintegrate. Time travel via gravity. The next method of time travel is also inspired by Einstein. According to his theory of general relativity, the stronger the gravity you feel, the slower time moves. As you get closer to the center of the Earth, for example, the strength of gravity increases. Time runs slower for your feet than your head. Again, this effect has been measured. In 2010, physicists at the U.S. National Institute of Standards and Technology (NIST) placed two atomic clocks on shelves, one 33 centimeters above the other, and measured the difference in their rate of ticking. The lower one ticked slower because it feels a slightly stronger gravity. To travel to the far future, all we need is a region of extremely strong gravity, such as a black hole. The closer you get to the event horizon, the slower time moves, but it's risky business. Cross the boundary and you can never escape. Gravity can slow down time. Credit Wikimedia Commons. And anyway, the effect is not that strong, so it's probably not worth the trip. Assuming you had the technology to travel the vast distances to reach a black hole, the nearest is about 3,000 light-years away, the time dilation through traveling would be far greater than any time dilation through orbiting the black hole itself. Time travel has long occupied a significant place in fiction. Since as early as the Mahabharata, an ancient Sanskrit epic poem compiled around 400 BC, humans have dreamed of warping time. Lisa Yashek, a professor of science fiction studies at the Georgia Institute of Technology in Atlanta, told Live Science. Every work of time travel fiction creates its own version of space-time, glossing over one or more scientific hurdles and paradoxes to achieve its plot requirements. Every work of time travel fiction creates its own version of space-time, glossing over one or more scientific hurdles and paradoxes to achieve its plot requirements. Others take a more whimsical approach, like the Doctor Who television series. The series features the Doctor, an extraterrestrial Time Lord, who travels in a spaceship resembling a blue British police box. People assume, the Doctor explained in the show, that time is a strict progression from cause to effect, but actually from a nonlinear, non-subjective viewpoint, it's more like a big ball of wibbly-wobbly, timey-wimey stuff. Long-standing franchises like the Star Trek movies and television series, as well as comic universes like DC and Marvel Comics, revisit the idea of time travel over and over. Thank you for watching.